In the 17th century, humans watched the tides rise and objects fall, possessing absolutely no idea why it happened. Into this world of deep physical mystery, Isaac Newton was born prematurely in 1642. He was incredibly frail, reportedly small enough to fit inside a large cup, and the people around him did not expect the infant to survive the winter. He did survive, but his childhood was marked by isolation. His father died before he was born, and his mother left to remarry when he was just 3 years old. Retreating from the loud play of other children, Newton kept to himself, sitting in corners to build small models of windmills and trace the movements of shadows. This early separation from his peers forged a specific asset. It gave him the capacity to sit in absolute stillness and pay complete, uninterrupted attention to the natural mechanics of the world around him. When Newton finally arrived at Cambridge University as a young man, he discovered a sanctuary built for his mind. He consumed the works of early scientific thinkers like Galileo and Descartes. In his small room, he filled pages with numbers, studying the stars and expanding his grasp of natural philosophy. Then, the Great Plague swept across England. The resulting devastation forced Cambridge University to shut its doors, scattering students and teachers across the country into immediate quarantine. While society panicked over the rapid spread of the illness, Newton simply retreated. He packed his things and returned to the quiet isolation of his childhood home at Woolsthorpe. Completely severed from his professors, his classmates, and the university library, Newton was left entirely alone with his own observations. This total intellectual vacuum meant that any progress he made would have to come from his own internal logic. The period from 1665 to 1667 became known as his miracle years. With nowhere to go, Newton turned his patient solitude into a personal laboratory. Sitting in a darkened room, he passed a single beam of light through a glass prism. He proved that pure white light is actually composed of every color in the spectrum, which fanned out against his wall. But he quickly hit a wall. He realized that the physical universe is in a constant, fluid state of motion, and the rigid mathematics of the 17th century were insufficient to measure how things change over time. To solve this problem, he invented a system to calculate the instantaneous rate of change. He called it the method of fluxions, a tool we now know as calculus. Decoding the hidden structure of light and inventing calculus are achievements that secure a place in history. Yet for Newton, these were the preliminary tools he needed to answer a much larger cosmic question. This brings us to the apple. Popular myth suggests it hit him on the head and granted him instant genius. The reality is that he simply observed an apple falling in his garden, and using that immense capacity for attention, asked a highly specific question. Why does the apple fall strictly straight down? Why not sideways or up? He deduced that it must be pulled by a massive invisible force, dragging it toward the center of the earth. Then came the leap. He hypothesized that if this invisible force extends to the highest branches of a tree, it naturally reaches into the sky. And if it reaches far enough, it must eventually reach the moon. This was the birth of universal gravitation, the idea that every single object in the universe exerts a universal pull on every other object. Holding the mechanical secrets of the cosmos made him intensely cautious. Fearing public criticism, Newton locked these calculations away in his personal notebooks and refused to share them for 2 decades. The man who mathematically proved that every mass in the universe is bound to every other mass spent his own life almost entirely apart from other people. Fast forward 20 years to 1687. After 2 decades of private refinement, Newton finally published the exact mechanics of his universe. He released the Philosophia Naturalis Principia Mathematica, the definitive text that introduced his physics to the world. Inside were his 3 laws of motion, providing rules that explained precisely how force, mass, and reactions dictate all physical movement. Scientists across Europe found that Newton's math worked everywhere, linking the motion of the planets with the simple physics of a pebble on Earth. Because of one man thinking in a rural room, humanity awoke to a new reality. The physical world was no longer an unpredictable mystery. It was a highly ordered, measurable, and predictable mathematical system. But the order of his physics stood in contrast to the reality of his personality. He was famously difficult, engaging in a bitter feud with Gottfried Wilhelm Leibniz over who had actually invented calculus first. Behind closed doors, Newton also spent immense amounts of time studying alchemy and theology. He was searching the ancient texts for hidden meanings and divine architecture that went far beyond his mathematical formulas. In his final years, he moved to London, served as the Master of the Royal Mint, and was eventually knighted. When he died in 1727, he was buried among royalty in Westminster Abbey. Despite the scope of his achievements, he maintained a grounded perspective on his own work, famously writing that if he had seen further than others, it was by standing on the shoulders of giants. Ultimately, Newton's legacy is the proof that uncovering the mechanics of reality doesn't require sudden magic. It begins with the persistent willingness to pay absolute attention to the ordinary world and simply ask why.